Section 10.4 is on page 482. Talks about even and odd functions, and this is where we're going to start saving some time. See? Okay. And we know from algebra, if f of negative x equal f of x, f is an even function. If f of negative x equal negative f of x, that's an odd function. And this is what I mentioned from calculus, something to keep in mind. So they're asking, are those even or odd? This is how you play the game. You call this f of x. You throw a minus in for x. That's negative x cubed minus 2 times negative x plus 1. And you see, you simplify. If the negative disappears, it's an odd function. Well, this doesn't match. All what you do, you factor a minus out of it. If this is what you started with, then that's an odd function, otherwise it's neither. And do you see that doesn't match because of the 1? Neither. What if I have a secant of x? F of negative x equals 1 over the cosine of negative x. And what do you know about cosine? Cosine is an even function. It absorbs the negative. So isn't that just the secant of x? This is an even function. E to the negative x, well, if you call that f of negative x equals e to the minus negative x, f of negative x equal e to the x. If you factor a minus out of it, that will be negative e to the x. That doesn't match the original. Neither. You could always look at a graph, and a graph of an odd function is symmetric with respect to the origin. A graph of an even function is symmetric with respect to the y-axis. So, if I look at 7 through 12, it says a function f is given on an interval in each case of length L. In each case, sketch the graph of the even and the odd function. So first, let's start with the function itself. This function is 0 between 0 and 1, right? Included, not included. And it is going to be x minus 1. If I put a 1 in there, I get a 0. And if I put a 2 in there, I lied, didn't I? Okay, from 0 to 1, it's 0. So that's the original function. And if I put 1 in there, I get a 0. If I put 2, I get a 1. There's the original function f. Now, I'm going to run assume it's even. If it's even, it should match so this is going to be the even. And the odd, I'm going to run it in red. If this was odd, it would be symmetric with respect to the origin. It would have looked like this. So this is the odd, and this is the even. Alright? And if I went to the next problem says, if x equals 0, I get a negative 3. If x equals 4, I'll get a 1. The function looks like this. If I wanted this function to be, let's go for even first. If I want it to be even, I want it to be symmetric with respect to the y-axis. So 1, 2, 3, 4, 1. The whole graph, everything, the black and the purple will be the even function if it was even. And if it was odd, I need it to be symmetric with respect to the origin. So, oh, this point is not included. and this point is not included, so I gotta make sure that's not included. And if it was odd, then I'm gonna go 1, 2, 3 above, not included. And if I move 4 to the right, 1 up, I'm gonna move 4 to the left, 1 down. And how am I getting that? Well, actually, I gave you that already. If you're given points, for even, take every x, y, multiply the x by a negative, the graph is there. If it's odd, multiply the x and the y by a negative. 0, negative 3. If you multiply them by a negative, it becomes 0, 3. And 1, 4. If you multiply them by a negative, it becomes negative 4, 1. If you multiply those by a negative, it becomes negative 4, 1. Right? Alright. And if we go to the last problem, this is a graph. If it's 0, I am at 4. And if it's 1, I am at 3. So the graph of f looks like this originally. If I want to go for even, then all what I have to do is, and those are not included, all what I have to do that's even. Oops. And if it's odd, just multiply the x by a negative and the y by a negative. Well, 0, 4, 1, 2, 3, 4. And 1, 3, negative 1, negative 3. That's the odd. And that's how it works. So, pretty much, since I know that, if I have a even function, an even function is going to eliminate really b sub n. And an odd function is going to eliminate a sub 0 and a sub n like we did in the previous section. So if you know that, you could save yourself a lot of work. And here's a problem. They say, find the Fourier series for the given function. B, sketch the graph of the function to which the series converge over 3 periods. Well, the graphing part we just did. So, I'm gonna run y equal x. If I put a 0 right there, I'll get a 0. If I put a 1 in there, I will get a 1. And 1 from 1 to 2. Basically, there it is. And if I want to graph 2 more periods, there's 1. You could do 1 to the left, 1 to the right, doesn't matter, but all good. There it is. That's 3 periods. That's part B. Part A, find the Fourier series, and notice what they say do in this section. They specify they only want the sign. And they tell you what the period is. If the period is 4 units, which is 2L, that means L is only 2 units. Alright? Now let me point out one thing. The period is 4 units. But did you notice they only run from 0 to 2? And why is that? Because they're using even odd. If they use even odd, they're going to give you half of the period. So, what's the catch? The catch is when they say find the sign, you're going to say f of x equal the series n equal 1 to infinity. So, if they say the sign, it should be this. But if they say find the sign, they're telling you that this is a 0 and this is a 0. What's the catch? The catch, anytime they tell you that, when you say, well, okay, then all what I have to do is find b sub n and I'm done. B sub n normally is 1 over L, the integral from 0 to 1 of x times the sine of n pi over 2x dx plus the integral from 1 to 2 of 1 times the sine of n pi over 2x dx. However, since you're only doing a sine, or if they say a cosine, you really double the actual integral. And that's how it would work. So what would this would be? This would be 2 over 2, which is a 1, times. If I use parts on this, and we did that too many times, that would be negative x the cosine of n pi over 2x. If you divide by n pi over 2, you end up multiplying by the reciprocal, plus the sine of n pi over 2x times 2 over n pi squared. This is evaluated from 0 to 1, plus, and this is nothing more than negative the cosine of n pi over 2x times 2 over n pi evaluated from 1 to 2. And if I evaluate those two, pretty much I'm done. This would be, if I throw the 1 in there, negative 1 the cosine of n pi over 2 times 2 over n pi plus the sine of n pi over 2 times 4 over n squared pi squared minus, if I put a 0 in there, that's a 0, and if I put a 0 right here, that's a 0. Okay, this piece is going to give a negative cosine. If I put a 2 right there, the 2's cancel out, n pi times 2 over n pi minus, if I put a 1 in there, I'll get the cosine of n pi over 2 times 2 over n pi. Well, that's a 0. That's a 0. So I'm really looking at a negative 1 to the n plus 1, right? Because you start at pi over 2. At pi over 2, that's a 1. There we go. Times 4 over n squared pi squared minus a negative 1 to the n times 2 over n pi. So if I really set this to be b sub n, I'll be looking at f of x equaling the series n equal 1 to infinity. What can I take out of this? I could factor out of this 2 over n pi. I would have a 2 times negative 1 to the n plus 1 over n pi left, minus or plus a negative 1 to the n plus 1. That's pretty much it. Or a minus negative 1 to the n. It makes no difference. That's the coefficient. The sine of n pi over 2x. And that would be my final answer. So in this case, when they say find the sine or the cosine, keep in mind cosine means this is even and you're gonna really get the a sub 0. If they say sine, that means a sub 0 and a sub n are 0. And here's another problem, like I promised. In this case, they say find just the cosine. Well, only the cosine. That means f of x, it should be a sub 0 over 2 plus the series n equal 1 to infinity of a sub n, the cosine of n pi x over plus b sub n sine of n pi over, and let's see how that works. Here they say the period is 8. If the period is 8, which is 2L, that indicates that L equal a 4. There we go. Well, if they say find the cosine, that means that's 0. All what I have to do is find a sub 0 and a sub n. A sub 0 is, it should be 1 over L, the integral from 0 to 4 in this case, of x squared minus 2x dx, except what I'm going to do, the catch, I'm going to write a double it. Again, they gave us only half of the period, and that's always the price. 1/2 x cubed over 3 minus just x squared, evaluated from 0 to 4, 1/2 into 16 over 3 minus 8, minus 0 of course, that's 1/2 over 1, 3 times 3 times 16 minus 8 is, oh, I'm sorry, 4 cubed is not 16, 4 cubed is 64. 64, okay, I'm messing up everything today. If I put a 4 in there, that's 16. So that would be 1/2 into all over 3, 64 minus 48, if I'm not mistaken. That would be 1/2 of, and what is that? Okay, I have to use a calculator. I'm really bad with math, you guys. So there it is. I got half of the problem. What's left? The other half. And what is that? A sub n. Well, in this case, a sub n would be 2 over n, the integral from 0 to 4, of x squared minus 2x times the cosine of n pi over 4x dx. And we've done this quite a few times by now. So this is going to be 1/2 times, and if I use the u and the dv, I'll be looking at x squared minus 2x times the sine of n pi over 4x. If I divide by that, that's 4 over n pi, plus 2 minus 2x. I got it backwards. 2x minus 2. I don't know why I'm doing that in my head. I should just copy it down. Times the cosine of n pi over 4x times 4 over n pi squared minus, no, plus a 2, no, minus 2 times the sine of n pi over 4x times 4 over n pi cubed. And I'm going to evaluate that from 0 to 4. That's going to be 1/2. Now let me just, I don't like how that's squished toward the end. Times 4 over n pi cubed, evaluated from 0 to 4. So that's going to be 1/2. If I put a 4 right there, that's going to be 16 minus 8. The sine of n pi times 4 over n pi, that's a 0. Plus, if I put a 4 right there, that's going to be 8 minus 2. The cosine of n pi times 4 over n pi squared minus twice the sine of n pi times 4 over n pi cubed, that's also a 0, minus, if I put the 0 there, that's a 0. If I put a 0 there, that's negative 2. If I put a 0 there, times 1 times 4 over n pi squared. And if I put the 0 there, the sine of 0 is 0. So I'm looking at 1/2 into 6. Isn't that a negative 1 to the n times 4 over n pi squared plus 2 times 4 over n pi squared? And if I'm not mistaken, that would be it. Let me see how that works. If I distribute the 1/2 in, that's 3. Actually, this will make that a 3 and that a 1. I could factor a 4 over n pi squared. Let me see what's left. I'll have a 1 minus 3 times negative 1 to the n. Okay, that'll do it. So I would say f of x equal a sub 0 over 2 plus the series n equal 1 to infinity of a sub n, the cosine of n pi over 4x. A sub 0, I got that to be, oh, there it is, 8 over 3. So if I take 8 over 3 and divide it by 2, isn't that 4 over 3? Plus 16 over pi squared, the series n equal 1 to infinity of 1 minus 3 times negative 1 to the n. Of course, you could multiply this. You could say 1 plus 3 times negative 1 to the n plus 1. It doesn't matter really. Over n squared times the cosine of n pi over 4x. And that would be my final result. Okay, and let me get the homework up.